this? Day 8 of Advent of Code. We're almost a third of the way in. I will be solving problems in F-star, a functional programming language with dependent types. Let me just send a tweet out that the stream is starting. Happy Advent. Oops. There we go. So, welcome back. We're just a minute away from day 8, so I don't have a lot of time to go over any progress from yesterday. I checked into my GitHub account, which I will pull up here, so you can see all the previous day's solutions. And I did manage to make a little progress toward proving that the median is the correct solution for day 1. But I didn't get all the way there. It's tougher than I thought, and I'm disappointed because I thought this was really something that F-star would shine at, is proving that our algorithm really did find the optimum. Advent of Code is sponsored by. Oops, let me switch to screen share. So. Yeah, so there's my GitHub. I'm mgritter in GitHub. You can see my Advent of Code, all of my Advent of Code solutions there. My employer, Akita Software, is sponsoring Advent of Code this year. Check out our jobs page. We'd love to have you apply. And here we are on day 8. Okay. Okay, we've got a 7-segment display. Okay, we have 4-digit displays, and each one of them is wired up randomly. Okay, so you don't know. For each display, you watch the changing signals for a while, make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value. Huh. Okay, well, this should be interesting. So the first part, it asks us just to find how many times the digits 1, 4, 7, or 8 appear in the 7-segment display, which is the end of each line. So are they always in the same order, or are we going to have to change that? It looks like they could be in any order. Right, we got B here and then EDB. Okay. All right. Well, that's a non-trivial amount of work. I mean, we could do it by hand. I mean, it doesn't really matter what the patterns are because we know we just care about the lengths, right? So, all right, let's. I mean, I'm tempted to just solve this with like grep or something, but. All right, so let's see. We need our own old friend string. Um, maybe that's it. All right. So let's copy. All right. So let's. I was going to say let's parse the line. Yeah, that'll be good. We'll probably need this in part 2. So given a string, we want to return. In fact, let's write a record type. Okay. I can never remember how this syntax goes. So I'm gonna check in the tutorial. Where is it? Records. Okay. Okay. So type display is I don't know why it's so hard for me. Okay. It's the samples, which are a list of string, and they're the output, which is a list of string. Okay, so we split Oh, we need to start up the background process before we can get interactive help. Split, yeah. Um, so we need to do something about if it doesn't parse right. So I guess we'll just use an option type. All right, otherwise return this record, which is samples equals split index. We do need the list functions. Some can't type anything tonight. All right, length. Split. Okay, index. Split by space. That'll leave an empty one at the end. I'm not too happy about that. Unfortunately, we don't think string has a split that takes a string instead of a character. No, even index of just takes a character. That is unfortunate. All right. I don't. Ooh. I quit Emacs by mistake. All right, I'm not really happy here because both of these should be of we can split by a list of characters. Field of samples output. All right, I'm unhappy with this because these are both the wrong length. So let's trim them both. Okay. If length of So else let first part equals, take the substring of index x0 from 0 to it's just annoying. All right. All right. So we want to take the substring of the first part from 0 to 1 less than its length, and we return take. All right. And we'll validate that a little further. So this should be a list of string of length. Let me write this L. So list a string, and the length of L is 10 for the 10 possible digits. All right. First. All right, this is way overkill. But everything will be the right size if it succeeds. All right, if length first inputs 10 and length second inputs equals 4, then all right, how are we doing? Okay, good. So it'll only return none or a well-formed display object. All right, so for part 1, we just need to compute the number of 1, 1, 4, 7, and 8. So 1 has 2 digits, 4 has 4 4 has 1, 2, 3, 4 digits, has 4 segments. 7 has 3 segments, and 8 has all 7 segments, right? 1, 2, 3, 4, 5, 6, 7. Okay. So in good functional programming style, we should be able to just do, yeah, list count. Okay, so count takes an exact number. So let's map each display to the length of that display's output. So we convert a list of displays to a list of length for strings. Yeah, it's not quite as simple as I thought, but all right. We actually need to map. All right. So given a display, we're going to map the length function over its output. So to go from a set of Sterling, go from a list of strings to a list of integers of their lengths. Okay, and we want to map that over the inputs. Okay. And then we want to sum. So we'll use fold left. No, but I want its type. There we go. All right. So our function's going to take the total and the a segment count. So that's the that's the list of length 4. And it's going to return the old total plus uh, I'm going to go through that list and count up the number 2s and the number 4s and the number 7s and the number 8s. Okay. So there's our function, and we start with 0, and we have output segments. All right, does everything type check? Does not. Oh, it's our own old problem with the ints and nats. So hello, welcome to Advent of Code in F star. It's a functional programming language with dependent types. And it's one of those dependent types that's giving me a problem here. Nat is int refined to be greater than or equal to 0. And it doesn't know that those are this. It says I got a list of nats. So let's just tell it this is a list of nats. Will that help? All right. Well, this is dumb. All right. Can I just tell it that that's a nat? I've been fat fingering like crazy today. Okay, that which hello. This is F star is a research language out of Microsoft Research. Microsoft also has F sharp, which is somewhat related. You can compile F star to F sharp in theory. It doesn't work too well. I compile it to OCaml, which is ML. Have you heard of ML at all, or OCaml? It's also somewhat of an obscure language. Oh well. Uh, yeah, the nice thing about OCaml is it's much better documented than F star. So if I don't know what something looks like in F star, I can usually look it up on OCaml and find it because they base the design off OCaml. But right now I'm just having difficulty having it prove that if we add some nats together, we get a nat. Oh, it's not the right syntax. All right. Am I using the right symbol for... Okay. Says, I think that should be a natural number, and it says that's not how you use that. I don't know why not. All right. All right, we'll back up. We'll say our function takes a natural number and a segment count that's the list of nats, and it returns a nat, and it's all that in All right. So we've got the parsed input. We map the input to the length of each of the output digits, and we count the number of segments, which I think is what they asked us to do. So now we just need to open up a file and parse the input, and I'm going to copy my old code from day one as the starting point. Okay, I should have gone back a day, because we need to read until we hit the end of file, which we did a few days ago. All right, there it is. Okay, so we're gonna, instead of a line cards, we're gonna turn back a list of displays. Okay. The order doesn't matter, I think, but it's fine. So we're gonna do parse line, and we're gonna actually match that, because that, if that returns an error, then we'll just say, we couldn't parse it. And if it returns a display, then we're going to put that display at the beginning of the list and keep reading. And because this is the, width. Okay, good. So okay, so we got our list. And we just need to print it. And I didn't open the right module. FStar's IO is pretty primitive. It's more meant to be prove out things and extract code to pull into a different program than to really build whole programs in. So this is sort of a stretch for what FStar is doing. So Aneurysm asks, I wonder if FStar will make this puzzle easier. My experience is no. It's never easier to actually prove that your program is correct than to just write it and hope it's correct. All right. All right, and then let's do our usual thing. We'll call calc part 1 on example, and then on the whole input. I should just have this as a boilerplate in every directory. Okay. Oh, it's sprintf. All right, let's try it. Oh, we don't. We didn't copy the example. That's no good. I even missed the last line. I suppose the other thing I could have done to avoid all that messing around with truncating the string is just go in here and remove the spaces around. I probably should have thought of that. All right, let's see what happens. Interesting. So the extraction failed. We found a bug in the F-star code generation. Right? It verified it correctly, and then it output ML that didn't compile. Huh. Let me look at that a second. So some of this code is translated, others use ML or F sharp code. So F star list to base. Hmm. Right. So see the implementation of the length function calls an OCaml function and turns it into the appropriate type that F star uses for its integers, which is this type Z, which I don't know. I'm not an OCaml expert. Whereas the count function doesn't wrap it, and I think that's what it's complaining about is, hey, you're trying to add something that's an integer, a special integer with the normal integer. All right. So I'm gonna copy this actually and report it as a bug later tonight, but we can just put our own count function. That was exciting. We'll just we'll put our own count function in, and there should actually be one already described here. So we just need to copy it and give it another name. We don't even need to give it another name. That should override the one that's there. All right. Let's see if everything's happy there. Unknown error from parsing. So, did we give it the wrong name? No. Can we do this? Oh, I wonder if it's this exception. All right, let's do some printf debugging. Let's try the obvious thing first. Do we have a spare new line? We do have a. No, I think we're good. Okay. Print string. Okay, so we'll say input, and then the string concatenation is the caret operator. So we don't have to use. What's going on here? Okay, oh, that was the problem. All right, so we're not parsing correctly. So let's see. Because this is a total function right now, it's hard to put printfs in there. There's no debugger. X. You know what we can do though is we can define a new type that will show us what the error is. So we'll either get a okay oh, we can't capitalize this. It's dumb, but we can't. So we're defining two constructors for our type. So we either get okay or we get a parse error, and we'll return what the string is. So change this to a parse result, and then we can give names to all these. So parse error short after. They just need to be distinct. let's get fancy. Width, length, first inputs, length, second inputs. All right. Okay. Colon. There we go. All right. So here we will. Okay, we'll adjust this to parse error e print string. And otherwise it's okay. Parse. Oh, we didn't parameterize it. We could have made parse result that took anything as its argument, but okay. All right. We're back in business. Let's extract that out. Links are wrong. 10 and 11. How can that be? All right. Huh. Why did it let us do this? So, okay, so I messed up here by not putting in second part. But why? It should have stopped us because we don't know that there's that many characters in first part. Right? Like if we put it if we take a substring that's too long, it shouldn't work. What's the type on that? Right, it needs to prove that the first and second arguments are less than or equal to the length of this. So I don't know why that it shouldn't have been able to prove that that substring was okay. Right, this is the huh. All right, that's another to do. I'm surprised at that. Okay, so still having problems though. Oh, because they're the same string. Okay. that explains it. So I made two mistakes. Uh, all right. So it says the answer to part example is 26, which is not what we got at all. No, but that's not the full 3, 4, 5, 6, 7, 8, 9, 10. There should be 10 lines. Oh, because we skipped everyone here. We didn't do this. All right. That is still wrong. Okay. So let's make sure that this list has the right length. Exactly 4. All right. It says expected type nat list nat, and it got our more specific type. So what's the type on fold left? Interesting. I wonder if we can't use fold left on a list with a refined type, because this isn't parameterized by something on. Let me copy that. Okay, expected. I feel like it ought to have been able to say, yeah, that works, but all right, what else can we do? So we should be able to say this is the same as if we We could calculate it another way and prove that the two are the same. That might uncover our bug. Uh, right, we could count all the twos, we could count all the fours. Um, hmm. I didn't think this was going to be the hard part of the puzzle. Are we screwing up our truncation? Like if we remove the last element of the list, then our of the string, then our count would be wrong. Uh, Looked right to me, but can we prove? Could we maybe prove that if we spit it back out, we get the same thing? Um, it's going to be a problem because sub doesn't have a model. So we have to add a bunch of axioms about how sub behaves, which I did in another library, but that causes a problem. Okay. Let's print, instead of printing out the parsed version, let's print out the, okay. Right, so this is the function we would use if we wanted to prove they were equal, but I think we would not be able to do so. So this will just be, particularly if you want to prove something about sprintf, that would be very difficult. So concat. Is there a join? I hope there's a join. No, there isn't. Oh no, concat is what I want. Concatenates the strings in L delimited by S. Okay, so we're going to concat with a space. Uh, I'll map that over d.samples. And so those are two strings, and we want to concatenate them with the vertical bar. Oh, yeah, we didn't need to do that. I thought they're still strings. All right, so let's, while we are parsing, instead of doing this, we will do display to string D with a new line at the end. Semicolon. All right, let's do this just on the example. No, that looks right. So it's got to be some more basic error in how we're summing things up. Yeah, that looks the same. All right. The problem with printf debugging in F star is we can't print out things like lists or other structures easily. We'd have to, the standard printf is not good at that, so we'd have to do a bunch of work. Oh, all right. I switched from the first column to the second column. So we want to count 2, 4, 3, or 7 segments. Okay. Okay. I don't think I could have written a type to help me out with that. All right, all right, we got 26. Let's see if this value is right. Okay. Yes. Our solution is getting less elegant by the minute, unfortunately. All right. So it says the mapping between signal. All right, we have to determine the remaining digits. All right, so we're going to need to plan how to do that. So we're going to have to deduce the mapping. So if we look at the 7 segment, uh, so we know 1, and we know 7, and we know 8, but 8 doesn't help us because everything's lit up, and we know 4. So if we know, I'm looking for which ones help us out here. Like, can we deduce? All right, so 1 and 3 overlap. So do 9. All right, so let's make a table. Okay. So 0, 1, 2, 3, 4, 5, 6. All right, so 6 segments has to be 0, 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5, or 3. 1, 2, 3, 4, 5, or 5. 1, 2, 3, 4, 5, 6. 6. We already got 8 and 1, 2, 3, 4, 5, 6. All right, so we can break them up further by the number of segments. So 0 and 4 have 3 segments not in common, right? So everything else we need has this middle. I'm looking at the middle row here. That 0 doesn't have it lit, and everything else on our list does. So how can we identify it? So 0 doesn't have lit, but 6, 2, 3, 5 do. All right, so we could deduce which is the middle segment by looking for what do 1 and how are we going to do this? Okay, so we know AAA is in 7 but not 0. And then equals in 4 but not 1. And we know EE equals in 9 but not 8. But 6 causes us a problem there too. We should. I think we should draw a Venn diagram. That's gonna be messy. Right, that's 1. That's 4. But 8 is, so that's 8. Right. All right. So if we look at 2, 3, and 5, only one of them will have both C and F in common with 1. All right. So in why did I say 0? Something's wrong. Oh, but not 1. All right. in 3 and 1, but not okay, so that tells us which two are C and F, but we don't know which one. All right. And that gives us 3. So we know I'm wondering whether I should get the code to figure this out instead of me figuring it out. We could do that. We could write it as a satisfiability problem where we sort of put in what we know and iterate on can we prove anything else. But that's likely to be a lot more complicated than just encoding the logic once I've worked it out. All right, what has B and D? So 6 and 9 have BD. So they're in they're in 6 and 9, but not 0. Okay, so we've identified. All right, so now we know 0. We know 1, 4, 7, 8, 0, and 3. Okay, so we can figure out. I think this last line doesn't help me. So how do we distinguish 2, 5, 2 and 5? So 2 overlaps with 7. Nope. We need to. So who doesn't have a C set? It's just him. Who doesn't have E set? So E. Okay, so if we have 5 and we union it with 1, we get 9. And if we take 6, except we don't know which 9 is. All right, so 9 union 1 equals 9, right? So that's how we can distinguish it from, oh, we can't. All right, we already know 0. So that's how we can distinguish 9. Once we know 0, we can distinguish 9 from 6 by that. So now we know 9 and 6. And now we just need to distinguish 2 and 5. So so 2 intersect 2 union 5 is 8. 2 union. Wow, I shouldn't be doing these puzzles late at night. Should be doing them at 10 in the morning when I'm fresh. All right, so 2 union 7 is a backward 6. That doesn't help. 2 union 1 is also backward 6. Doesn't help. 2 union 4 is 8. But 2 union 5 is not. All right, let's try writing that. That may not be the best decision tree, but I think we've got it all set up. So the other thing we have to deal with is they're in random order. Does that matter to us? All right, what data structure do we want to hold these? I think okay, a lot of pieces to write here yet. It'd be interesting to see who does this in a very concise way. Um, And we're going to interpret everything when it comes out. So let's do it in 2 phases. All right, let's write string equality. I guess I'm heading the direction just leaving everything as strings. That doesn't seem right though. I got bitten by using set earlier, and so that's why I'm a little shy of doing it, because we can't actually get the members of a set out as a list, but we can inquire whether they're there. And can we do equality? We can do equality of sets. All right. Sure, let's do it as a set of. And then hopefully we don't have to worry about ordering. All right. So we do list. So we do as set list of string s1. Oops. This is part 2. Okay, good. And we also need a map. I feel kind of bad about mapping sets to. We map integers to sets. All right. And we can build the reverse if we want. All right. So if we're given the 7-segment display value, then that gives us an initial map from set of characters to the integer. Between 0 and 9. I hope that, no, we want to go the other way. All right, so let so S1 is yucks. So it's gonna give us a hard time. Uh, because we can't guarantee that all these exist. So we're gonna have to use try find or make the function not pure. All right. We want to find in uh, we find the sample whose strlen equals 4 equals 2. All right, so that's 1. And let's not make the same mistake I did last time. So 4, 7, 8 is 4, 3, 7. So it should be you know, do a pattern match. And if that's the case, then we'll do something. Otherwise, uh, otherwise we'll fail. But I'll just return an empty map. Is that the right function for an empty map? Contains the constant mapping. Huh, how do we get... I don't want the constant map. I want one where it decides if the key is in the map or not. I'm not sure why there's not an empty map. Update. Maybe it's time to look at an example. Hmm. That's interesting. Hmm. Guess I should have tried using it. So that we know that the map internally as a pair of key and values. It's a pair of it's a record that has the mappings and the domain. So what keys actually exist. But that's not in the interface. So maybe this is a bad choice, but I'm really puzzled. I thought I would be able to use this, and the only way I see to construct a brand new mapping is to use const. But then everything is in the map, which is definitely not what I would like. Okay. Unfortunately, I don't understand most of these examples either. Good night. Sorry, I'm not making much progress here. Uh, s- um, no, const isn't a good thing to search. It doesn't actually use that, it just opens it. Uh, okay. That works. That seems like it can't be the right thing, but let's go with that. All right. So what this says is take the constant map. Yuck. All right, we're gonna need to just we're gonna need to define a type for this. So equals map.t from that to that. Okay. So empty which returns a digit map. So we want the constant map that uh, returns the empty set of characters. Does that type check? I bet it doesn't. That's not even syntactically correct. Oh, it got stuck. Oh, what went wrong there? All right, we pulled in another concat. A lot of the standard library functions use the same names. So we have to specify which one we mean. Okay. All right, amazingly that worked. So what we did is we created a constant map and then we just threw everything away and said restrict it to the empty set. I'm not sure why that's what we need for an empty set, but all right. So now we can build that map up an element at a time. So one will map to the set. And two will map to that, and we should give these consistent names. All right. 7. All right, does that work? Let's do Sterling of Fooey. We have to do it in the other order. All right, map update. Yeah, the map comes first. That's very inconvenient. All right. So empty 1 goes to that, 4 goes to that, 7 goes to that, 8 goes to that. All right, so that's our initial calculation. And then how do we determine 0? So can we express this in terms of union and intersection? Okay, so 0 intersect uh, so this may have been a mistake. All right, so B or D equals for set difference 1, and then six and 9 both have that, and 0 does not. So uh, B or D is not a subset of 0. And similarly here, 1 intersect 3 equals 3. All right, let's write those. So uh, so the set of zero, 6, or 9 is the ones with string that thinks 6, and the set 2, 3, 5. Okay. All right. I'm worried that STR is going to make this very difficult because we know that these hold, and F star is going to say you haven't proven that they hold, and proving that they do seems like it's just as hard as solving the puzzle. So I don't see a good way to do both simultaneously. Could we just assert that uh, mm, something that we could assert that it's a permutation exists, but I think the easiest thing is to make these impure functions. All right, so we've got our candidates for 2, 3, 4, and our initial one. So equals init. I just don't think this map function is very usable. Select. All right, so if all right, we just want to iterate through those. Be so much easier if we knew that it's all right. Is there a better way, fundamentally better way to go about this? Should we, instead of a map, should we have a I don't know. All right, we're going to take out our set from the one. We're going to try we're going to find the one where this is true. select. Oh, phooey, it's not a Boolean. It's a proposition. It's not a constructive test. Well, that's not going to work at all. Yeah, I ran into this problem on a previous day too, that sets are more about for reasoning with than actually using. There's no cardinality. There's no... Okay. So I can use bit vector and I'm going to have to convert each letter to a position. And can I check that they are equal? Yes, so they have equal type, which means it's a type with equality. All right, so segments. This is a bit vector type of length 7. And we need to can convert it to an int or a list of booleans. Okay, so this might cause us problems because because 7 may be too long for it to know that literals are the right length. Contains char there just a simple membership check? Mem? No, we don't have a member relation for lists. For strings, we got index, and we need to know how long the string is. Oh no. Index of. Okay. All right. Return. Oh, not return. Index of C in. That's backwards. Index of is not equal to -1. Okay. So BV list to BV. So we're going to curry contains char and run it over the list of characters. We need semicolons. D, E, F, and G. Okay, good. So digit map is going to be from the integer to the segments in it. Okay, we need to map to the int to bv of 0. Well, and for all the right, no, int 2. Okay, good. All right, that type checks. So now we need to say if BV, so intersection is going to be and. list of segments. Okay, well, that type checks at least. So that says let's write a test case. So if we're given oh, that's so painful. How do we create the right list? So we need to do string to segments. So if we've got 5, which is normal form is A, B, D, F, G, and we've got string to segments. Oops. 2, 3, and 2, 3, and 5. 2, 3, and 5. A, B, D, F, G. And our initial map is okay. So there's our argument, and one is just CF. So that should be equal to I don't know if you can do that either. And all right. Okay. We will instead of doing equal, we'll say that select 3 equals that one. Okay, our test passed. uh, that took a surprisingly long time to run, but the normalizer is not meant for actually executing long pieces of code. But it worked. All right. So now we can uh, map 2 equals infer 3 of S235 and our initial map. All right, so the next, let's call that M3. So the next thing we can do is infer can infer 0. So it's not going to type check, but we can worry about that later. All right, so we know so B, the BD segments are the union of those. No, the symmetric difference. So we want in 4 but not 1. Do we have that, or do we have to? We have to. What have we got? We got XOR, OR, and do we have not? There it is. Okay. So that is, oh, we can just do XOR. Okay. So in 4 and not in 1. This one's a strict subset. All right, so we've again got 3 candidates, and so we need, a non-zero, no, let's see. We need to say it's a subset of everything but zero. So the one it's not a subset of. So subset is, I can just write this. So if A is a subset of B, then everything in A is going to be in B. So A union B equals B. So if BD is not a subset of 1, then that's 0. Okay, that's 2 digits down. So what's next on our list? Nine union 1 is 9. Because we got rid of 0. We should be able to infer both of them actually. So one of these, when we look it up, all right, so we need 0 and we need 1. And I'd really like to remove the one from the list that's, all right, so let filter, except the filter's like, not gonna ask us. I think we need to go and start using the non-total functions that can fail. So we use list tot dot index but the nth function can fail dynamically. I really hate doing this bit though, because we're making well-behaved inferences based on the information we know. So it'd be really nice to encode that as a type so that f star knows that too and can check our logic. And I'm afraid I just don't know how to do that. So it's getting late. I'm gonna shut down the stream, I think. Because this approach is very tedious and it doesn't seem like it's the right thing. And maybe a night's sleep will give me some ideas about how to do it in a better way, or at least a less tedious way. All right. Good night. Thanks for staying up with me. We will see you tomorrow, and hopefully we'll make more progress on tomorrow's problem.